I'm Dave Kassler, amateur radio call sign KE0OG, and welcome to Ask Dave. In this episode, we're going to continue a conversation with Ray Nelson, N1MPD. I first spoke to Ray last July and put together an Ask Dave video at the time about his specialty, which is coax. MPD Digital is an organization formed by Ray Nelson and his wife, and they make coaxial cable assemblies. So they buy coax by the mile, and they make assemblies for amateur radio, all different kinds of radio, like for cell towers and things like that, for the military, for commercial uses, even inside MRI machines. Their cable is everywhere. And Ray has become an expert on all different kinds of cable and all different kinds of things that can go wrong. So today's conversation is going to focus on coax versus water. And we'll talk about waterproofing cables, some things that you can do. We're also going to talk about this rip-off coax that you can get online that may claim to be like Times Microwave LMR 400 or something like that. I just encountered some, quote, 400 cable a couple weeks ago that was nothing of the sort. And sort of how to tell that you're getting the right thing. Now, Ray Nelson's company is called USA Coax, or you can go into Coax USA. Both of them work if you put the .com after it. And his real organization is called MPD Digital, as in November 1, Mike Papa Delta, MP Digital. And if you go to that website, and you can order anything. You can order coax assemblies basically of any length. You can order bulk coax, can order all kinds of things. We had a great time talking. So let's dive right into the interview with Ray Nelson in September of 2017 and see what's going on. Let's talk about coax and the novice again. We hear people say things like coax goes bad in 3 years, or, oh, that coax has been outside, it's no good. How do you tell? What goes wrong with coax?
I'm glad you asked. What I have here in my hot little hand is a 6-month-old piece of coax that came here. We made it. We built it. If you look at it, it's RG213. It looks almost brand spanking new. Can you see the inside of that?
No.
How about if I go like that?
A little bit better there. Yeah, it looks kind of ugly inside.
Yeah, it's basically green. You know how copper looks after it's been sitting outside in the weather for about 3-4 years?
Yeah.
Got that green verdigris on it. Well, that's what the inside of this coax looks like, and it's only 6 months old.
Really?
What that tells you is that the person who hung this up against their tower outside did not waterproof their connection at all. And once water starts dripping its way down inside this coaxial cable jacket, what you end up with is wonderful, joyous looking coax that basically your entire signal goes bye-bye. It gets dissipated into heat. Now, in this case, that's an extreme case. However, a lot of the times it happens gradually over a long period of time. You get more and more moisture buildup inside the jacket. Your shield turns green. Your gets all gummed up. Then your center conductor starts going, and you start noticing your SWR shoot up, and you start noticing that your propagation is going down. In a lot of cases, it happens so gradually that you don't really realize that your connectivity is only about a third as good as it was 5 years ago. So when you hear people talking about coax goes bad over a period of time, a good quality coax should last you 15 to 20 years outside. as long as you properly waterproof your connections and you don't chew the cable all to pieces.
Yeah.
Jacket, that is.
Or let the
So,
animals do it.
or let the animals do it. Yeah, we, yeah, or let the porcupines get to it because porcupines love to eat cable jackets for some reasons. Um, the thing is that most people don't consider that, and they don't think about, oh yeah, that's got shrink tubing on it, that's got heat shrink on it. Well, it doesn't matter. If water can get in there, it will. So use a good quality, the self-fusing silicone tape that Times Microwave makes is about the best thing out there. There's
Hmm.
several other brands of it too, or a good 3M um water sealant, waterproofing type tape that they use for waterproofing electrical connections. Use something like that on the outside of your connectors and your connections to your antenna. The other thing is to make sure some antennas are fiberglass and they're hollow on the inside.
Hmm.
And if water gets on the inside of that antenna, it feeds it right down into the coaxial cable. So make sure that if you've got an antenna that's prone to getting water down on the inside of the fiberglass or the inside of that tube, that you have a weep hole or something so the water can drain out before it goes into your antenna connector and your cable. I've seen guys literally that sent cable to us where water went in one side and 50 foot away it came out of the other side. They unscrewed it from their radio and they had water dripping out their other end of the cable.
Ooh.
So it's not good stuff, and water will kill coax faster than anything else out there.
Now, how can you tell if you've got a length of coax like that one that you had there that looks like it's good, but you can't tell? Do you have to tear it
On the
apart to
outside it
see?
looks perfect. Yeah, on the outside it looks perfect. The only way to tell really is to use an antenna analyzer or time delay refractometer or refractometer, excuse me, or something else that basically will measure a path through your coaxial cable and tell you whether or not there is a signal there's a signal reflection coming back from not quite a short, but a place where uh, it'll show up just like if you crush the coax
Mm-hmm.
and you severely change the length or the distance between the shield and the center conductor. It'll show up basically as an obstruction in your signal path,
Mm-hmm.
and that's an easy way to tell. The other way to tell is to run a simple sweep the way we sweep all our coax here. Unfortunately, a continuity test will not tell it.
Uh-huh.
Um, your impedance may vary off. So if you've got a good meter where you can check the impedance and see whether you've got variation there, you might be able to tell real quick. Or if you've got a way to check your capacitance, that's also going to change.
Mm-hmm.
So the internal aspects of the signal path are going to change, even though the coax on the outside looks perfectly fine.
Uh-huh. Okay, so if what do you recommend to the new guy who goes to a ham fest and sees piles and piles of coax under this guy's table?
Right.
Should he run or what?
It, I'm going to give you my legal answer. It depends. Uh, the reason I say that is because unfortunately, coaxial cable is one of those things that is so heavily counterfeited, mismanaged production wise, and frankly fraudulent in so many ways. I mean, there are literally millions and millions of dollars worth of lawsuits being fought in various courts right now over wire and cabling coming out of some of our Far Eastern communist neighbors.
Hmm.
Um, to the point where some countries have actually banned the importation of copper wire from China.
Really?
If you, yeah, there's a couple of countries that if you look, the Cabling and Wire magazine publishes a lot of continual articles to update the cable community on what's going on. But if you look, you'll see that there was one country that's a neighbor of China's that traced 53% of house fires to electrical wire that was being imported from China and used in construction. And there's several companies in the U.S. right now that built large stadium complexes that are being sued because the cabling, when they got 2 years later, is not up to spec. And they bought it from their distributors, fully expecting that it was great stuff. And on the outside, it looked great. On the inside, it was just as much tin as was copper. Tin's a whole lot cheaper than copper.
Yeah, but it doesn't conduct very well.
Yeah, exactly. It doesn't conduct worth a damn, but it's a whole lot cheaper than copper. It reflects pretty well. Here's some good examples that I bought. Everything I'm going to show you basically here was bought online from major venues like eBay, Amazon, Walmart, Newegg. One of the things we do with Times Microwave is I started working with Lou Caruso about 5 years ago, and Lou is the senior sales manager there at Times. And they were having such a huge problem on Amazon and eBay. He said, "Can you help us take down some of these guys?" And we have. So we order a lot of coax that's claiming to be LMR this or LMR that, and then we help them file the complaints and take down some of the offenders. But I don't know if you can see this cabling here, but this was sold as LMR 400. There's no markings at all on the cable jacket.
Really?
There's nothing there. It's polyethylene jacket with no identifying markings. The center conductor on it is bronze, not copper. Very brittle. This outside shield is aluminum, not copper, tin copper. And then the inner shield is aluminum tape. What you get when you run this through a test is you find that until you put about 500 watts through it, it performs okay. After, from 500 watts up, you can hang it up. You get more heat than you do signal.
So that's interesting. I was helping a fellow ham in the club put on some connectors on what he called LMR 400. And it was marked something 400. And it was thinner than the LMR 400 that I'm dealing with. And every time I would put any kind of torsion on the center conductor, it'd break off.
Right. The shielding and wire would break right off.
Yeah.
Because it's aluminum.
It's
because it's aluminum. You will find that a lot of the cabling that comes like this, that's supposedly LMR or supposedly Times Microwave, it'll come saying something or other 400, or it'll come saying LMR 400. A good example is this stuff right here, which if you look says LMR-195 ROHS. Well, Times Microwave doesn't mark cable that way. But if you strip this down and you look at the inside, that's what it looks like. Now, Times Microwave LMR or real LMR cable does not have a 5 single strand copper braid on the inside. That, by the way, this is supposed to be LMR 195, which has 20 gauge center copper wire. This wire actually is 22 gauge.
Oh boy.
And this is pure aluminum here on the shield. It's all aluminum wire. And if you twist a connector on it, I can pull this loose with my fingernail and break it. There's a bunch of it. I just pulled it loose with my fingernail. It broke right off.
Yeah.
So what you got there is you've got LMR 195. This was shipped directly from China after being ordered online, and basically, anytime if you try to screw a connector onto this, it's going to break right off. The
Yeah.
shielding is going to break right off. This one here is an example. This is RG58, RG58U.
Yeah.
Sounds right. Well, we do cabling and work with a couple of medical machine manufacturers.
Mm-hmm.
And most people don't know it, that if you've ever had an MRI, when you're laying there and it's going clunk-de clunk-de clunk, the signals are actually being carried in MRI machines by coaxial cable.
Yeah.
It carries the signal from the control panel, and the data is flowed through coaxial cable. Now, the manufacturer got this cable in and sent it to us saying, something's not right here, Ray. So I looked at it and found out that, okay, this is aluminum on here on the outside. It was supposed to be RG58U. So what you've got is a few tiny strands of aluminum shield. You've got some aluminum tape, so they get a shielding between the two. And then you've got this center conductor wire that's very, very stiff, solid, and looks like copper until you put a magnet on it.
It's steel.
It's steel. What happens when the MRI machine contacts steel? Anybody that's ever been through an MRI machine knows that they make you take off anything metallic or anything that could be magnetic, because all MRI machines are is a bunch of magnets running around.
Right.
So here it is, they were using cabling, and they were sold cabling that had a steel center conductor that was copper plated, and it says RG58U. And you know what? This is 100% legal, because there are no standards for RG type cable. There are no standards at all. RG213, RG58, RG8, RG8X is whatever the manufacturer chooses to make as a standard. The military specifications that are adhered to by U.S. manufacturers, because the military is a lot of their business, have very, very strict standards. But there are no international standards for RG cable types. They can make them out of anything, and they do.
Now, there was a story in QST about cable, maybe a year ago, that said RG213 is still an active specification.
It is in the military, yes.
Yeah.
That's correct. There's an active mil spec M as in Mike India Lima dash 7 mil spec MC17 mil C17 mil dash C dash 17, and then there's a separate mil spec that goes on to that called JAN dash C dash 17, and then there's a slash after that 17, 76, 32, whatever, and that slash and the additional two numbers after the slash define the exact military manufacturing codes and say exactly what the tolerance specifications are, the specification for precious metals, the specification for the dielectric, the jacket. Yeah, the military doesn't play around when it comes to cabling. The U.S. military, and they've also been adopted in the NATO STANAGs, and NATO STANAG is the same thing as the U.S. mil spec, basically.
Yeah.
Those are still very, very defined, and when the military buys RG213, RG214, RG58, RG223, all these, all the cable we stock here in the warehouse, you'll see it comes saying what military specification it was manufactured to.
Yeah.
That's the only way you can make sure that your cable is manufactured with pure copper or with the proper dielectric or a non-contaminating jacket, is if it meets that military specification.
How does the average purchaser know if it does?
You're going to have to ask. You're going to have to ask to see the specs. Anybody selling cable should be able to send you the specification sheet from the manufacturer that details exactly what's inside that cable, what it's made of, where it's manufactured, the quality of wire. All that is in the specification sheets, and any criteria it meets. Underwriter's laboratory, mil spec, a whole lot of different stuff. As an example, the RG8U that I had made up, because while 213 is still a valid military standard, 8 is not. The big fat nice RG8 that we all used to use is no longer a mil spec because it was preceded by 213. Well, there's nothing wrong with good old 8U. So I had it made up, and I had it sent and UL tested to Underwriter's Laboratory, because I had to have some specs and some criteria. So I used the UL specifications on it for copper purity and things along that line, and the ability to handle heat and all those other fun stuff. So basically, any good manufacturer will be able. I mean, I don't care if it's us or DX Engineering or Times Microwave or Consolidated or Coleman, Southwire, any of these guys. If you say, "Give me the spec sheets," they'll email you a spec sheet, or they'll have them posted. If you go on our Amazon listings, for example, on 90% of our listings, we've got the specification sheets posted right there. You can click on them and download them. Mm-hmm. Likewise, on our website, you can click on them and download them.
That's good.
Because, you shouldn't have anything to hide here. And coax is part of that system, that if you don't get the signal to the antenna, it doesn't matter how much you paid for your radio.
We mentioned, excuse me, waterproofing earlier in our conversation, and you mentioned several different types of tape. Could you describe just exactly how you would waterproof, say, the connection of a coax to an antenna? What would you use, and how do you know you've done it right?
Okay. There is a set of... Times Microwave has an excellent video, and we've got it hosted on the Times Microwave page on Amazon.com, or you could just Google Times Microwave self-sealing tape video, and they'll bring it in. But there's a specific way to apply that, because it only adheres to itself, and it has to be stretched at least by 25 to 30% as you're wrapping it, and overlapped, and you're starting below the connector, wrapping up over the connector, and continuing on to the antenna base to make sure that all that water is shed. The nice thing about that self-fusing silicone is that, unlike coax seal or some of the sticky stuff, when you need to cut it off, all you have to do is nick it with a knife, and it unravels just like a rubber band.
Yeah.
And it leaves no residue behind. It's easy. So that works really well.
Now, do you have to do something in addition for UV protection?
No, it's automatically built in. If you want it to seal like immediately, it normally will take it a couple of 3 hours to actually seal after you wrap it. If you want it to seal immediately, hit it with a heat gun or a hot air or a blow dryer, and hit a little bit of heat on it, and you'll see it, and it'll tighten right down and seal everything up tight. That's the best stuff I know out there. The other thing is the 3M C130 splicing tape works good, because it's the same type of stuff. 3M also makes a Model 70 tape that's the same type of stuff. 3M makes several products that are designed basically for the commercial electrical industry, the guys that are up on poles and splicing wires and stuff along that line. And it's essentially carrying over that type of technology into the amateur radio market and the commercial radio market, because Verizon and AT&T and everybody uses the exact same stuff on their cell towers to keep everything dry.
Now, I've noticed when I've wrapped some stuff with this 3M tape, it was black with a blue backing on it, that it seemed when it was out in the sunshine, it sort of disintegrated a little bit. It would crack and open up. So I've been putting that on and then putting just electrical tape over it for the UV seal.
That certainly won't hurt. I know that the Times tape has no problem at all with UV.
Mm-hmm.
Um, and I mean, there's a couple other manufacturers. Comscope also makes it, uh, and we sell both of them. But there's several manufacturers that make that UV protected silicone tape. But yeah, and it could be that some of the, and you're right. Some of the 3M tapes do have an overwrap recommended. Some don't. It depends on the actual model that you get from the 3M type tape. Maybe it's 70 that requires, because I know which one you're talking about, that has the blue plastic in between the
Right.
strands or between the layers. We've got some on the shelf out here, but I've never read the instructions on it, because real men don't read instructions unless all else fails.
Could you talk just a little bit more, and then I think we'll close with this, how you would use an antenna analyzer to determine the health of a piece of coax?
Okay. We actually run here at the office, when we sweep cables.
Mm-hmm.
We use a Bird Sight Hawk, which is, as testing equipment goes, it's pretty cheap. It's about $4,200. Unfortunately, a lot of the a lot of that testing equipment is very expensive stuff. However, any of the devices that are capable of sweeping coax will give you a graphical chart, and you've probably seen the frequency graphs where it graphs out SWR in accordance with a specific frequency range. Started at 1.8 megahertz and run it up to 30 megahertz and do a sweep, and it'll tell you where your peaks and valleys are for a particular antenna. Well, the resonance, it'll tell you the same thing with a piece of coax.
Mm-hmm.
So what you're going to do to test out coax is put a dummy load on one end to terminate the coax, put the other end into your antenna analyzer, and then sweep it at a specific frequency, just as you would your antenna, to see if you were resonant. And it'll quickly tell you, you'll see some really nasty SWR spikes, or some really nasty spikes when you get into looking at it, that will appear completely abnormal to the way it was when it was first installed.
Mm-hmm.
And that's a real easy, simple test. The other, as I said, your capacitance is going to change, your inductance is going to change. Everything about that cable is going to change as it gets water infiltration, or as the jacket goes bad.
Yeah.
Because if you've got jacket contamination, the same kind of stuff happens, where literally that rubber melts into the outer shield, and then you end up with the outer jacket stuck to your dielectric, and kind of interrupting the flow of the outer shield on your cable. And that's what happens a lot of the times if you see a piece of cable after a lightning strike or an EMP. We got some cable in a few weeks ago. It's still under warranty, so we replaced it. But the guy sent it to us, and I just had to laugh, because we cut it open, and it looked like, on the inside of it, it looked like a charcoal briquette. I mean, it was just nasty. And essentially, it was, he had a lightning transient. He never even realized it, because it never made it into his equipment, because his lightning protector stopped it. But it did fry. It fried like a 30-foot section of a 50-foot length of cable. I mean, it fried it bad.
I had something similar happen to me with a direct strike. There was a point down the cable that just blew out. I mean, literally blew up. It was quite something. Now, I have much less exotic antenna analyzer, the MFJ 259B.
Right.
And there's a setting in there where you can test coax loss.
Your loss will go up significantly higher than the rated standard.
Yeah.
And thank you. I'm glad you brought that up, because it completely slipped my mind. Yeah, if you're testing your loss and your cable is rated, you should be having 1.8 dB of loss for 50-foot length.
Right.
and your loss is at 3.3 or 4.6. The highest I've ever seen was 11 dB loss in a
Wow.
50-foot length.
Wow.
And that was, I mean, this cable here that's green on the inside,
Yeah.
it should have this cable should have been at 1.2 dB loss for the length he was running, and it was at 4.6.
Ah.
So, that'll tell you right there. And I'm thank you for bringing that up, because that's even easier, because your loss is going to go up significantly, because basically your signal path is being interrupted and reflected back to your radio.
Right.
And what isn't being reflected is turning into heat, because when you take a copper wire and you run a signal down the wire, and you interrupt that signal, where you interrupt that signal is going to generate some heat.
Yeah.
And the hotter and hotter it gets, the worser and worser it gets.
Okay. I appreciate your time today. We've filled up, I think, a time slot for a video. So I'll
Okay,
give you a call in another month or two, and we'll continue.
love to.
Well, that was a fun conversation, and I hope it helps people understand coax better and what they can do to make their coax last longer, and how to avoid getting ripped off by bad imitation coax. There's so many of those things out there today. Next time, Ray and I are going to talk about connectors, cable connectors of all shapes and varieties. For his customers, he can basically offer cables with any connector you want, or any combination on the two ends. He's making one for me right now that will connect from a male phono plug to a BNC male, so that I can take the IF out of the back of my FTDX 3000 and put it through a separate software-defined receiver and get a much more detailed SDR display. I'll put that in a future video. Also coming up in some of the videos is talking about volunteer examiners, and I've got one where we take a look at this key right here and see what's so special about it. Thank you so much for watching. Please click like, please share. Please also subscribe, and then when you do subscribe, click on the bell icon. That way you get immediate notification when there are new videos via email. And use both feet when walking, and we'll see you next time, 73.